All right, so today we're going to look at exceptions to the Aufbau principle.
One day you're gonna die and I'm jumping into your
Exceptions to the Aufbau. And back to chemistry. All right, so there's always exceptions to the rules, right? So remember the Aufbau principle, that was the one that told us what? Electrons fill in from.
Left to right.
They go one by one until there's no more seats left, and that's the double up.
Like one by one, what? No, but you're thinking of Hund's rule.
Oh, stupid.
Hund's rule is the one where they don't pair up.
They go into one. They go into one.
Right, that's where they go from lowest sublevel energy sublevel available. They'll fill in the
Okay,
lowest
that's
possible
like-
energy before they start filling in the next higher
That's like
energy
common
sublevel and
sense.
so on. And it keeps building up. Okay,
That's common sense.
but there's some exceptions to the Aufbau principle.
You guys.
They're none like they're just like they're glue.
They are.
Yeah, they're definitely.
It says they're glue.
Why would they be
They're
doing
so
that?
But it's not even that they're that good. I was just so hungry for the reason, and I really had more coffee than a week.
I'm gonna make pizza today, guys. Oh my god, that's actually what I was thinking as well.
Wait, what's the pizza again? Why did I flip? Cheese.
Cheese is only good one.
Pepperoni's okay too.
He said, would you guys pick up monkey on the street?
Yeah.
And I was like, yeah. And he was like, well, what's this?
Somebody that watches. Including said, I'll start picking up. Put gloves on. Put it in the zip line. Exchange it at the bank. Obviously.
Like, hey, this is coming to prove. Is this still actually
Valid.
you don't have any?
All right, so the first exception to the Aufbau principle that we're going to take a look at. Sometimes a D sublevel will become half filled or filled before an S sublevel is filled due to the extra stability that's just so
You ready?
filled and half filled sublevels make the atom a little extra stable. Okay. And because of this, if it makes it stable enough, it'll actually defy the Aufbau principle, and the electrons are filling in around the nucleus. We're going to focus on 6 different atoms on the periodic table, 6 different elements that are exceptions to the Aufbau principle. There are more than 6. We're only going to focus on 6. There's a lot down in that F block in the lanthanide actinide series that we're not going to worry about. We're going to look at ones that are in the transition metals. More straightforward and follow this particular exception. Okay. And I put them into like 3 sublevels.
Calm down, Mr. Five.
The first ones we're going to take a look at are, they're all in the same group: copper, silver, and gold. Okay, I'm going to focus on all of them together because they all do the same thing, just with different kind of. Walk out, sort of play a lot. So let's take a look. Copper, silver, and gold are all in the same family. That's why we're focusing on them all together, because they all kind of do the same thing. Just in different energy levels, but their sub-levels do the same thing. So let's take a look at silver. Okay, silver is number 47. So first, let's just follow our rules. Let's just follow the rules, okay, of electron configurations and put down what we would expect it to be following our rules. And then I'll show you how it's different. Okay. And it's going to be the same idea for copper and gold.
Can we do it in the shorthand?
Sure.
notation?
Let's do shorthand.
Okay, so first thing would be the KR.
Oh, no.
Hey guys, who's next?
No. I did good now.
I can't do like this.
I'm no longer.
Yeah, I
All
can
right,
help you
so
do it.
if we're going to do shorthand notation,
KR in.
right, you look at the noble gas that we just passed, right, to get to silver. So the noble gas that we just went by to get to silver is krypton, right? So we say, okay, silver has the configuration of krypton,
And then it'd be.
and then we pick up where krypton was left off. Right, and since silver is in the 5th row,
5s squared.
the first thing we're going to go through is the S block, right?
There's more people in this one.
What's that?
There's people.
More people?
Hey guys. Hey guys.
More people.
Can I have a cheese?
No.
This is-
Yeah, I don't think so. Oh. I do live in the big.
Is it recording? Yeah. Understandable.
Are you innocent or you bad?
Angel Christian.
In some ways.
Bad
I am.
girl.
Like, have I ever kissed someone? It was Miss Nell, you know, she has. I'll send the box.
My first email.
Hey, recording.
We have the 9 would be.
All right, so,
4d to the 9.
right, and then silver is, that's what we would expect, right? That's not what actually happens. That's what we'd expect. We expect, we go through the S block and then we're 9 into the D block. And remember, the Ds are always one energy level behind, right? So since we're in the 5th row, it's 4 Ds that are filling in. But this is not the actual configuration for silver. What happens instead, only one electron goes into the S. And 10 go into the D.
Now, what is the reason?
Yeah, what was the reason?
Well, if you look at what I wrote up there, sometimes the
Yeah,
D
but why?
sublevel will be half filled or filled
the
before an
extra
S sublevel because of the extra stability that half filled and filled
So
sublevels
why is
give
it,
you.
why does it extra stable?
Okay, anytime you have a sublevel that's either filled or half filled, it makes the atom more stable than if it has sublevels that are neither half filled or filled, but just kind of like in between. So right now, everything up to this point is filled, right? All through to the configuration of krypton. Everything was filled up there. With only one in the S sublevel, that's still half filled, right? S1, because we can only put 2 electrons into an S sublevel, right? So if we have 1 in there, it's still half filled. With 9 in the D sublevel, it wasn't filled or half filled, right? D can hold up to 10 electrons. With that extra electron, now that's filled. So we have all filled and half filled subunits. Okay. So that makes that more stable, makes the atom more stable with that configuration. And we check the configurations experimentally. They get the configurations experimentally. Then we try to figure out.
Really popular.
No.
Then we try to figure out
I do.
why that occurs. And that's
Get out. Get out.
why. Guys, I'm- You weren't here for the
No,
ceremony.
you're
See, I think I should get it out.
You have to let me know.
I bet I can do.
All right, so does that make sense?
I bet
As
I can
to
do.
why.
He's gonna do it.
Well, these are gonna be similar. The only difference is copper's in the 4th energy level, so it's just gonna be 4s1, 3d10.
Yeah, I know.
Okay. Gold is in the energy level above it, so that's gonna be 6s1, 5d10.
She was gonna do that.
Okay, so I got, but I'm doing it. Sorry.
So they do the same thing. That's why I
She said
just
knock it
picked
up.
one. All right. Let's take a look at the next group. There's only 2 in this group. We're gonna look at chromium and molybdenum.
And these aren't gonna be on the test?
These won't be on the quiz tomorrow. They'll be on the website.
Why not?
You're so I'm kidding. I'm
Yeah,
not.
I don't ever test you on
You're
something.
very fortunate.
So, yeah.
With a great mind. He's not Mr. Shut.
All right, so chromium and molybdenum are here in the D4. Now, for some reason, tungsten and seaborgium, just they're rule followers. They don't break the rules. They're not exceptions. It's only chromium and molybdenum that are the exceptions.
So they're not cool.
Okay,
Some be part on.
so let's take a look at chromium for this one. Okay, chromium is number 27.
Okay, so from my saying,
I think it says 20.
All right, so for chromium, let's just do the full configuration for chromium, not the short,
okay, I guess it's fine.
just for practice.
So
and for
it
fun.
goes to the.
So what's the first thing we go
It's
through?
24.
Yeah,
It's 24.
Oh, I was seeing if you're paying attention.
Yeah.
Well, we all.
So chromium is 24. Yeah, sorry, I looked at the ball.
I get you. I got you. You're all good.
All right, so chromium's 24, but let's do the full configuration,
So I think.
just to have more fun. What do we go through first? What's the very first sublevel? 1s2.
Mine, so.
Okay, so in the first row, all we go through in the first row is an S sublevel.
Sorry. Got from the comments.
Okay, what about,
She was aiming for-
what's next? What do we go through in the second row?
Two S.
First thing we go through is the 2s, right? We go through the S block. Okay, we go through the S block and then what?
Two B.
E. We don't have any D block in the second row, right? Second and third rows, there's no D block. So we go through the S and the P.
Then 3S.
Okay, this.
All right, the third row again, we're gonna go through the S and the P, right?
Maybe. Yeah, obviously.
Stop.
Okay.
3D.
Well, what do we got to before 3D?
Oh. Yeah, literally, it's
Oh,
right.
And then how many into the D block are we? 4.
Four.
And
But
the
then
Ds
it's
are always
3D4.
1
3D4.
behind, right? So it's 3D.
Because when I go to normal.
That's what we would expect, right? That's what we would expect.
No.
But this is not a rule follower.
So what is it?
What do you think is going to happen here based on the fact that half filled and filled subalmost makes the atom more stable?
I think it's gonna be 4.
The 4s will go to the 1 will go to the 3D because that'll make both of them happy.
Right, so instead of both of the electrons going into 4s, only one electron goes in there. And we have 5 in D because now everything is filled or half filled, right?
Oh,
Yeah.
So these are all filled and these are both half filled.
That's true.
That makes it more stable.
Who's speaking? What?
The same thing happens with molybdenum, it's just an energy level higher. So it'll be 5s140. Okay. For some reason though, tungsten and seaborgium just keep the S2 and 4,
I get you, man. I get you, man.
even though they're in the same family, they don't do the same.
You can get to like walk up to the lunch line and just get it out.
Questions on that one?
Probably. No question.
All right. And the last one we're gonna look at with this exception.
Why are you farting?
Palladium. And palladium is all on its own.
Stop
Um,
farting.
Nickel, nickel, palladium, platinum, they all do something different.
It's like.
Nickel is the rule follower. That one's the rule follower.
I like nickel.
Palladium follows this exception. And for some reason, platinum ends up with a D9 and
Platinum's
S1,
a bad.
S1, D9. I don't even know. We're not even
It
gonna
doesn't
pay
follow.
attention to platinum.
Platinum.
Platinum's an off-ball. So palladium is number.
Platinum's an off-ball.
Palladium is number 46. Okay, palladium's number 46. We'll do shorthand for this one.
So KR,
Obviously.
So if we're following the normal rules, we'd say KR and then what?
Wait,
probably.
5s squared, 4b8.
Yeah.
Whatever this is.
Okay, if we were following our normal rules, right? It would be 5s2 48.
Yeah, and it was actually gonna be 5s149.
No.
No, that's
All
what
the-
platinum does, but that wouldn't follow this.
All the 2 are gonna go to the 8.
Yeah.
What's that?
2 are gonna go to the 8.
Right, so there's actually not going to be any electrons that fill in the S. They're all going to go into the 4D.
4010. That's so
So
crazy.
now everything is filled.
That's so bad.
So there are no electrons that go into the 5s. And again, this is verified experimentally. We just experimentally they come up with the configurations, then we just try to explain the explanation as to why we believe that it does that. All right, questions on any of those?
With. Guys, I can get to today because I'm doing ice cream and cake.
Oh, in Miss Nels.
Yes.
I'm
Should I get?
No, not next year.
Yeah. Like a chocolate strawberry vanilla ice cream.
You have
Strawberry. Oh, yes. I don't think anybody else probably is thinking when I signed up.
That's well, then it's all for you and
Yeah.
Yeah.
Because someone's gonna bring a cookie.
That's not very fair if you're the only one who breaks it.
All right.
Just don't share.
So the second exception,
What is it?
Say, I'd love to know.
Oh
Sorry,
my god,
I was
I'd really like
picture of
that. Like, honestly, genuinely, I want.
Emily.
Did you get a picture of that? Seriously, did it take her yesterday? I don't have yours. I just ate.
Tomorrow or today? Tomorrow.
practice today, she can't play.
Wait, is there another game tomorrow?
It's Emily, so girl
Alright.
is the girls.
Is it here?
This applies to elements
Lanthanum.
in the lanthanide and actinide.
Where's that? That's so great.
That's the ones that they removed. It's the ones down at the bottom.
Okay, that's.
Okay, so this applies to the elements that are in the lanthanide and actinide. Okay, one electron fills into the higher D sublevel before the F sublevel is filled in. So notice on your periodic table in rows 6 and 7 how there's like a gap here.
That's where they're supposed to be.
We took,
Info.
I shouldn't have it one here. We took these and put them here because if you notice, there's a big jump in atomic numbers from here to here, right? That's because we take a detour down here and go through, then come back up.
Happy day.
Okay. So lanthanum and actinium, they actually just took right out of the periodic table and brought it in here, but notice how they're part of the D block, right?
Sure.
Lanthanum and actinium are the first ones, the D1.
That's crazy.
And then the rest of the elements follow them in the F block. Then we come back up and continue through the D block, right? So there's one electron that actually goes into the D before we start filling in the Fs. Okay. So let's do an example. How about if we look at samarium?
Oh my god.
Okay, it should be a good samarium.
Cassie's so smart.
I didn't know.
She predicts the future.
I'd just like to point that out because most people think that this was named after P.A.'s Celsius, but it's really
Yeah.
samarium.
Would it in shorthand would actually?
Right, so if we do shorthand notation, this is part of the 6th row, right? So we want to look at the noble gas at the end of the 5th row before we start filling in the 6th row. Right? So it's going to be xenon. So it's xenon. Then we go through what block?
6S2. 6S.
Okay, and then we hit 1 into the D block, right?
Yeah.
Because we're removing all this out of here. And the first, we're only 1 into the D block before we remove that. So the D's are always 1 behind.
5D1.
So 5D1. And remember, the F's are 2 behind, right? So if we're in the 6th row, we're filling in 4 F's. And how many into the S are we for samarium? 5. Okay, samarium after lanthanum, samarium is 5 into the F block. Okay, does that make sense?
Yeah.
So whenever you're doing elements in the lanthanide and actinide series, you just have to remember that you have 1 in the D block. Start filling. Once you're beyond there, it doesn't really matter because you're continuing to fill into the B block after that, so you just count how many. Just remember that you've already gone through the steps. Don't forget to do that. All right, does that make sense?
Yeah.
All right, now it's your turn.
I'm glad this so much. ¿Cómo se dice? ¿Cómo se dice Shana? Cállate.
I want you to do the configurations and I'll let it be your choice. You can do shorthand or full configuration, whatever you want to do.
Oh my god.
For
No.
molybdenum, which is number 42.
It's not.
seen the dot low.
Copper, which is number 29. And uranium,
Uranus.
which is number 92.
You say Uranus is next.
My dad says they're changing the name of Uranus to Erectum.
So it won't be weird.
Oh, so funny.
So people don't laugh about it.
It's actually Uranus.
No, it's
not.
Uranus.
It really isn't.
The scientists told us so.
So practice with these. Pause.
Yes, they're
All
gay.
right, so
A lot of the rappers are public inside.
are there any questions on the correct configurations here?
No, I think we really did them actually.
So here, that occurs because then our S and our D are both half filled, right?
Yes, I understand.
This one occurs because then our S is half filled and our D is filled.
Yes.
And then you just have to remember for the lamphite and actinide series, both elements in there, you always put one into the D and then the S there.
So do we get to choose the rest of the
You don't
period?
want
No. Or is there another rule?
brotherly love over
Another exception?
No.
Oh, cool.
Another thing before we start practicing for the quiz tomorrow, I had posted an announcement and put like a page that deals with diamagnetism and paramagnetism.
Thought our quiz was
I just wanna
Friday.
talk about that. Quiz tomorrow, just on straightforward electron configurations. and
Oh, wait,
assigning
tomorrow's
quantum
Wednesday. I'm
numbers.
seeing tomorrow's Thursday. And then,
So there won't be any of the exceptions on there that we talked about today. It'll just be straightforward ones, but it will be assigning quantum number values too. We can practice one of those together. But what is the main difference between diamagnetism and paramagnetism? Anybody read?
Oh, I did. I forgot you said it.
It's on your lap pack. They talk about it in your lap pack.
Diamagnetism is all of the electrons paired.
Right.
Did you just call me stupid?
No. She just called you fat. Okay, so-
And paramagnetism, they aren't, right? You have electrons that are not paired.
Guys, I don't know if we really have this one period.
Okay, so at least one electron in there is not paired up. Which one of these is attracted to a magnet?
The para.
And the more electrons that are not paired up, the more attracted it is to a magnet. So, for example, if you look at iron, I think that's 26, right? Yeah, if you look at iron and do its orbital notation, okay, iron's in the D block, right? So you get through the first 3 rows.
Why do you keep me?
Yeah,
Okay, so I used iron because we're probably all familiar that iron is attracted to a magnet, right?
Like Iron Man, yes.
Iron has 4 unpaired electrons. The more unpaired electrons there are, the more magnetic. Okay, diamagnetism repels a magnet. An example of this would be magnesium.
Yeah, I
Number 12.
fell on that. Magnetic thing with it. Wait, what is it? It's not miserable. Oh my god, I'm so sorry, excuse me.
She's not sorry. Don't even believe her.
Okay, so there's magnesium. There's magnesium, everything is paired up.
Yeah.
That's diamag. So that's the main difference between those. Questions on that?
No, I guess not.
All right, do you want to practice a few for the quiz tomorrow?
Oh, yes, please.
All right,
Close
I
your
had
eyes,
to
close your
put-
ears and your eyes.
I had put a practice sheet out for you to do on, under the quantum model module.
Do we do them together?
Well, if you look on the left, there's like a left side and a right side. If you look at the left side, why don't you do all the configurations for those, like the orbital notation, the complete configuration, and the shorthand notation. And then for aluminum is one of them. Assign the quantum number values for aluminum. Then we'll go over this one from there. But they're on Canvas. If you look on Canvas under the quantum model, it says electron configuration practice. Look at the left side of that. And let's practice those for the quiz tomorrow. I'm going to.
Close your eyes.
Great, so let's take a look at aluminum as an example for tomorrow.
Yeah, let's do that.
Sorry. I was making fun of.
All right, aluminum's number 13, right? Aluminum's number 13.
Yes.
So first, let's go ahead and do all of its configurations first. Let's do orbital notation first. What fills in first?
1s2.
So if we're doing the complete configuration, we'd say 1s2, orbital notation if we draw the arrows, right? What fills in next? Next 2 electrons go into the 2s. What's next?
Yeah, I know who. Oh, because look, we're just
3s.
Right, then it's 3s.
2. And then
Oh, wait.
That's 12 of the 13.
Oh.
Where's the last one?
3p1.
I'm stupid. Oh, yeah.
And those are the configurations, right? This is the orbital notation. This is the complete configuration, right? What if I was doing shorthand notation? What noble gas would I put in brackets?
Any, and then 3s to.
We pick up where neon left off. That's 2. Now, if we were signing quantum number values.
Yeah, let's figure this out.
Georgia.
I tested you. Ew, not these.
Okay, so remember the N
I mean,
represents the energy level.
yes, is that 3?
Even actually this before.
I think I've seen this, I just don't remember what we did with it.
So N, if you're in the first energy level, and it's 1, if you're in the second energy level, it's 2, third energy level, 3, and so on. L is your sublevels. We start at 0. We start at 0. But your maximum value is n minus 1. Whatever your energy level is minus 1. That's your maximum value for that. Okay, those are your sublevels. Remember, if L equals 0, what sublevel are we talking about? S. If L equals 1, what sublevel are we talking about? E. L equals 2. L equals 3. We won't ever go beyond that. So that's how we stop.
Oh wait, I have these stuff. I have Y.
I'm not doing anything.
ML represents our orbitals, right?
Yeah, I guess so.
I guess.
Tells us how many orbitals we have in a sublevel. Those values go from negative L to positive L, right?
Yeah.
I don't like these.
Okay, from negative L to positive L. And then what does the MS represent?
Spin.
Spin. So your two possible values, it's either positive or negative. Like that, right? So aluminum has 13 electrons. If we're assigning quantum number values for all of the electrons, we're going to have 13 sets of values. So let's
Oh my
start with
God.
the 2 electrons that are in the 1s.
I literally forget.
Well, what energy level are both these electrons in? They're both in the first energy level, right?
Yeah, I guess so.
And they're both in the S sublevel, right?
Yeah, so that means that their L is 0.
Right.
And then ML would be 0 for both, right?
Yep, because there is no
And
negative,
then it would
positive.
be
zero.
negative for the first one, positive for the second. So, because they're both in.
Right, so this represents the one spinning this direction, this represents the one spinning the other.
Yeah.
All right,
Okay. And then
now I just keep track of it. You don't have to write this out here, but I just keep track of it. They're the ones that are in my plans.
I guess I'm fine.
The next electrons are in the 2s, so it's going to be very similar to this,
so
right?
it's still 0, 0, positive.
The only thing that's different is the energy level, right? They're both in the second energy level, but they're in an S sublevel, which means there's only one orbital available. One's going to spin one direction, the other's going to spin the other.
Okay, and then the next one, there's 6 twos, and it's.
Right, the
the
next 6 are in the
1,
2p sublevel. So I'm just going to write all 6 of those down, okay, because they're all in the p sublevel.
1, 1, 1.
Right.
I
So
might have to
they're
see
in
that.
the second energy level, they're all in the p sublevel. How many orbitals are available in the p sublevel? How many
1.
orbitals?
3.
3. They go from -1 to +1, right? There's the first orbital, second orbital, third orbital, and then they just pair up, right? So the first 3, remember, they go in one at a time, spinning one direction. Then they start pairing up, spinning the other direction, right?
Wait, why is it, wait, no. Oh, wait, my mind. Okay. No, I don't know what's going on.
Okay.
So how many is that?
So second energy level, P sublevel, whenever you're in a P sublevel, your L value is 1. Your orbital values go from negative L to positive L, so -1 to +1. Okay, that gives us our 3 orbitals. Remember, they go in one at a time, all spinning the same direction,
So why is it?
and then they pair up, spinning the opposite direction.
If they pair up.
They're the ones that
there's a
pair up.
-1.
Okay. So -1, negative, -1/2, -1/2, -1/2, +1/2, +1/2, positive. Spinning the opposite. Does that make sense?
Yeah.
Let's move on to 3s. I'm going to rewrite.
Like, I only need 3 more.
And what, so 0 is still the L for that, right?
Yep.
And then, so it's still 0 for that, and then it's just positive negative.
So the 3s, we only have one orbital, right? One sublevel, one orbital, or S sublevel, one orbital.
And then,
Yep, any S sublevel is always an L value of 0.
and then 3 feet is only gonna be 1.
Right.
So it'd be
we only have one electron remaining, it's in the p sublevel. We start at -1, right? It goes from negative L to positive P. And the one lone electron is in there.
Yeah, why?
So I think I remember this. Can you, like, is there a worksheet that has stuff like this stuff on it?
Yeah, can you like post those?
I don't really have a worksheet, just pick elements to do them.
Okay.
But another way I could ask it is I could say assign
No.
quantum number values
When can we test for this?
to
Do
the,
that next week.
let's say to the D electrons for,
Wait, can you give us another one? Well, I want.
all right, well,
Okay.
this is nickel, so do the electron configurations, but then assign quantum number values to just the D electrons. Just the D electrons. Nickel is number 28.
Oh,
How do I? Okay, let's
But
start.
I
from
only
square
want you to do quantum number values for the D electrons.
one. Okay, okay.
Okay.
Can you walk me through this? I don't know. I literally don't know.
Okay. Do you want to do it together or do you want to try it? And then-
Well, they're trying it, so could you just help me?
Well, I do want to go over it too.
Well, yeah, but
We'll start off right in the configurations. You know how to do the configurations, right? Like the 1s2, 2s2, 2p6. Nickel, yeah.
what's after 4S?
If I had a nickel for every time somebody told me they couldn't do
What
this.
was it? 28. What's after 4P? 3D? Oh.
Okay, so let's take a look at nickel. So the first thing it's going to fill in is what?
One.
S. Second thing, 2s. The next one,
2P.
P. And 3s. And 3p. Right? S. Right, so for a D, we need 5 lines, right? Put in the first 5. Then we have 3 more. And there.
Oh my God.
All right, if you were doing shorthand notation, what would it have been?
AR 4S2 3D8. I don't think it's right.
Right, because this is AR's configuration, right? So when we put AR in brackets, we're really saying that. And then reading it. Now, if we're assigning quantum number values to just the D electrons, that means we're focusing on only these.
So that's like 8
So we're gonna have 8 values.
And so it'd be 3,
But no, D is 2.
That's what I meant.
Right, so they're all in the 3rd energy level, right? All 8 of those electrons are in the 3rd energy level. They're all in a D sublevel. A D sublevel, your L value is 2, right?
2. See, I was right when I said 3. I'm not a dummy. Yeah. I went 3.
They're all in a D sublevel.
Mm-hmm.
That means our orbital value ranges from what to what?
-2 to +2.
Right.
Ew, -2.
That's where we get our 5 orbitals from, right?
1, 1, 2.
That's our 5 different orbitals, and then we have 3 left that are pairing up, right? So we just start over.
-2, -1, 0. And then so it's gonna be, so like the first
Negative,
6 of them are gonna be
negative,
-5.
So the first 5 all went in alone.
Yeah, and then the other ones are gonna be positive.
Right.
Okay. I think I'm
The
gonna
last
say this
3
one
have to
percent.
pair up, so they're gonna spin the opposite direction.
I gotta study at lunch.
Oh, crap, me too.
Oh, yeah. I guess I'm gonna do
It's
that
just the
next.
road.
It's just the restaurant.
Questions on that?
Yeah, yes.
I don't, maybe we should ask her for a review date